Imagine a world where machines can think, learn, and even surpass human intelligence. It sounds like science fiction, but this dream has captivated humanity for centuries. From ancient myths of artificial beings to modern-day robots, the idea of artificial intelligence has fueled our imaginations and pushed the boundaries of what's possible. Today, AI is no longer a fantasy, it's rapidly becoming a reality, shaping our world in profound ways. As we stand on the cusp of this technological revolution, it's essential to understand the journey that brought us here. Where did this quest for artificial intelligence begin? How did we go from rudimentary calculators to machines capable of beating chess grandmasters and creating stunning works of art? The story of AI is a fascinating tapestry woven from the threads of scientific curiosity, technological innovation, and a relentless pursuit of knowledge. It's a story of brilliant minds who dared to dream of machines that could think like humans, machines that could solve complex problems, augment our abilities, and perhaps even unlock the secrets of consciousness itself. This is the story of the crazy history of AI, from sci-fi dreams to reality. In the next section, we'll delve into the early days of AI, exploring the groundbreaking work of pioneers like Alan Turing, and the birth of a field that would forever change our world. The quest to create thinking machines traces back to the mid-20th century, a time of immense scientific and technological advancement. Alan Turing, a brilliant British mathematician and codebreaker, laid the foundation for artificial intelligence. In 1950, Turing introduced the Turing test in his paper Computing Machinery and Intelligence. The test aimed to determine if a machine could exhibit intelligent behavior indistinguishable from a human's. It involved a human evaluator engaging in text-based conversations with both a human and a machine. If the evaluator couldn't reliably tell the difference, the machine would be considered to have passed the Turing test. The Turing test sparked widespread discussion about the nature of intelligence and the possibility of thinking machines. It became a benchmark for AI research, inspiring generations of scientists and engineers to build intelligent machines. Turing's work provided a framework for evaluating AI and fueled the development of early AI programs mimicking human-like thinking. Inspired by Turing's vision, the 1950s witnessed the emergence of the first generation of AI programs. These early programs, though primitive by today's standards, represented significant milestones in the quest for artificial intelligence. One such program was the Logic Theorist, developed by Alan Newell, Herbert A. Simon, and J.C. Shaw in 1955. The Logic Theorist was designed to mimic the problem-solving skills of a human mathematician, specifically in the realm of symbolic logic. It was able to prove mathematical theorems from the Principia Mathematica, demonstrating the potential of AI to tackle complex intellectual tasks. Another groundbreaking program of this era was the General Problem Solver, also created by Newell, Simon, and Shaw. The GPS aimed to create a more general-purpose problem-solving program capable of tackling a wider range of challenges. It used a method called means-ends analysis, breaking down problems into smaller subproblems and searching for actions that could reduce the difference between the current state and the desired goal. These early AI programs, while limited in scope and capabilities, generated immense excitement about the future of artificial intelligence. They fueled the belief that machines could be taught to think, learn, and solve problems like humans, paving the way for a new era of technological innovation. Section 4. The Dartmouth Conference, where AI was born. The year 1956 marked a pivotal moment in the history of artificial intelligence. The Dartmouth Summer Research Project on Artificial Intelligence, more commonly known as the Dartmouth Conference. Organized by John McCarthy, Marvin Minsky, Claude Shannon, and Nathaniel Rochester, this 6-week-long conference brought together leading researchers from various fields to discuss the potential of thinking machines. The Dartmouth Conference is widely considered to be the birthplace of artificial intelligence as a formal field of study. It was at this gathering that the term artificial intelligence was coined, and the foundational ideas, goals, and challenges of this nascent field were debated and defined. The conference participants, brimming with optimism, believed that significant progress could be made in creating intelligent machines within a generation. They envisioned machines capable of understanding natural language, translating languages, writing creative content, and even exceeding human intelligence in various domains. While the Dartmouth Conference laid the groundwork for decades of AI research, the path to achieving true artificial intelligence proved to be far more challenging than initially anticipated. Section 5. AI's Winter Unmet Promises and a Period of Dormancy. Following the initial wave of enthusiasm and optimism, the field of AI faced a period of disillusionment and setbacks, often referred to as the AI winter. The ambitious goals set forth at the Dartmouth Conference proved difficult to achieve, as researchers encountered fundamental limitations in computing power, data availability, and algorithmic understanding. The 1970s saw a decline in funding and interest in AI research, as early programs failed to live up to the hype and deliver on their promises. The limitations of early AI systems became apparent, particularly in their inability to handle ambiguity, common-sense reasoning, and the complexities of the real world. Despite these challenges, dedicated researchers continued to make incremental progress, laying the foundation for future breakthroughs. New approaches to AI emerged, such as expert systems which relied on vast stores of domain-specific knowledge to solve problems in specific areas. While the AI winter represented a period of stagnation and unmet expectations, it also served as a valuable learning experience, leading to a re-evaluation of approaches and a renewed focus on fundamental research that would eventually pave the way for AI's resurgence. As we emerge from the shadows of the AI winter, the dawn of a new era is upon us. The turn of the millennium brought with it unprecedented advancements in computing power, data storage, and algorithmic innovation. Machine learning, neural networks, and deep learning have transformed the landscape, enabling AI to achieve feats once thought impossible. From natural language processing to computer vision, AI has gone from being a crazy idea to something that shapes our everyday lives. Consider the smartphones in our pockets, the recommendation systems that suggest our next favorite movie, or the autonomous vehicles navigating our streets. AI is not just a tool, it is becoming an integral part of our existence, making our lives more efficient, connected, and enriched. But this is just the beginning. The question that now stands before us is, what do you think is the next step for AI? Will it be the creation of truly autonomous systems that can think and learn on their own? Or perhaps the development of AI that can understand and respond to human emotions with empathy? The possibilities are as vast as our imagination. One thing is certain, the future of AI holds boundless potential, and we are only scratching the surface of what is possible. As we continue to push the boundaries of innovation, the next chapter of AI promises to be even more transformative and awe-inspiring. Join us on this journey as we explore the limitless frontiers of artificial intelligence and discover what lies beyond the horizon.